Hello everyone. In this video, we will introduce two important notions, eigenvalues and eigenvectors for matrices. And we will do some basic examples. Later on, we will develop the theory and make everything look more elaborate and nicer in the other videos. Okay, let me start right away with the definition. So eigenvalues and eigenvectors are something that we can assign to square matrices. So let A be an n by n matrix. It must be square matrix, otherwise it doesn't make sense. Then a number lambda is called an eigenvalue of A. So eigenvalue is a number, or it could be a number. But how is it defined? If we can find if there exists a non-zero vector, it's important, it must be non-zero vector v such that A times v, so you multiply this matrix A to v, you get another vector v. That is just lambda multiple of the original vector v. So if you can find such a non-zero vector, then you're done. You found you have found an eigenvalue, which is the multiple, and that vector also has a name. The vector v is called an eigenvector. An eigenvector corresponding to eigenvalue lambda. So for any eigenvalue, you can find these eigenvectors, and then they should satisfy this equation. So when you multiply A to V, it must be lambda V. But where we start with these things, or how we find eigenvalues, how many eigenvalues a matrix can have, or how many eigenvectors, and so on. So these are the things that we will discuss in details. But in this video, we will do a little bit basic examples just to make sure that we understand the definition. So here a vector is given, and it is an eigenvector. So for this one and that one, these are eigenvectors are of the given matrices. The question says that check, show. Someone already found it, and now they're asking you to show that these are eigenvectors. What should we do? We have to multiply AV. So this is what we need to do. So we must show that AV is multiple of V. And that multiple is going to be the eigenvalue of that eigenvector. So we start with AV. This is just matrix multiplication, yes? The first row times the first column here. So it will be 1 times 1 plus 2 times 1. And negative 2 times 1 plus 5 times 1. And this will give me 3 there. So we multiply A to V, and now I want to show that this is multiple of the original vector that I started with, which is 1, 1. And you can easily see that that is 3 times the given vector. So what we showed is AV is 3 times V. Now, then you can say that V, which was 1, 1, is an eigenvector corresponding to eigenvalue. What eigenvalue? The multiple you saw there is the eigenvalue. It wasn't given. We found it. Lambda equal to 3. So if I have eigenvector, I can easily check, or any vector you give me, I can easily check if it is an eigenvector or not, and if it is, what is the eigenvalue. The same story goes here. Now I'm trying to find AV1216 negative 1 0 negative 1 negative 2 negative 1 and negative 1 2 1. So 1 times negative 1, 4 and 1, okay. Then negative 6 minus 2 plus 0 and 1 negative 4 negative 1. This gives me 4 minus 8 and again negative 4. So now to show that this is an eigenvector, I have to show that this is a multiple of the original vector that I started with. And you can easily see that that is negative 4 times negative 1, 2, and 1. So what we showed here is that V, which is negative 1, 2, 1, is an eigenvector of eigenvalue lambda equal to negative 4. So that's one side. If you know a vector, you can easily check if it is an eigenvector or not. The other side is also easy because, okay, not easy, but it can be done with some work. So here there is a lambda given. What is that lambda? In this case, I believe I dropped it, but it is lambda equal to 4. So the question says that, okay, there's a lambda, given lambda. Show that this is an eigenvalue of the given matrix. So what should we do here? We must show that to find a non-zero vector V such that AV is 4 times V. So we have to find such a vector. So if I set V to be X and Y, then I will start with AV, which is 6, negative 1, 2, 3 times X and Y. We have to show that this is 4 times X and Y. Well, or we find X and Y such that that happens. Well, let's write this as an equation. The left hand side first component is 6x minus y equals to 4x on the right hand side. And the second component is 2x plus 3y is equal to 4y. What can I do? So I can take all the equation one side, all the variables one side. So it will give me 2x minus y equal to 0. And that will give me 2x minus y again equal to 0. I see that these are same equation. They're just same thing. And it means that while one has no less information than 2, so the only thing I have in hand is this thing. But what does that mean? That means that the first, okay, so let me write it mathematically first and then show you what does it. This means that y is equal to 2x. So it means that the second component must be twice as the first one. Okay, so what we showed is this. any vector of the form, the first component could be anything, but the second component must be twice as that, double of that. Okay, satisfies AV equals to 4V. And since eigenvectors satisfying the same equation, but they must be non-zero, so you pick any non-zero number. For example, if x is equal to 1, this is 1, 2 is an eigenvector for eigenvalue or corresponding to eigenvalue 4. You can put x equal to 2, that's another eigenvector. Or you can put negative 10, that will be another eigenvalue. So all these infinitely many eigenvalues you can find, eigenvectors you can find there for eigenvalue 4. So this is the other side. If someone gives you eigenvalue, you have to turn everything in an equation form and then try to solve that one. Okay, how about this one? Again, so we have to try to find solutions for this thing here. So that means, let us just write that. 4, 2, 1, x, y, z, 6, 2, 0, negative 1, negative 2, 2. This must be minus x, minus y, minus z. So we go and try to write this one as the equation form. 6x plus 2y equals to minus y minus x minus 2y plus 2z is equal to minus 7. And from there, this is 5x plus 2y plus z is equal to 0. 6x plus 3y equals to 0. Minus x minus 2y plus 3z is equal to 0. Now, we have to solve this system of linear equations. But if you look at the video, which, what was the name of the video? Examples of determinant and invertibility in the previous unit, the first video of that, then you will notice that we solved this one and we found the solution. The solution for this one was this form. Any vector of the form x minus 2x and minus x is a solution. We found it before in another video. So in particular, we have shown that 1, negative 2, negative 1 is an eigenvector for eigenvalue or corresponding to eigenvalue lambda equal to negative 1. And you see that this way you can find all these eigenvectors. So what we showed here is that if you know one of these pair, either eigenvector or eigenvalue, finding the other one is straightforward. But now, what if we don't have any of these? That is going to be answered in the next video.